Optical instruments. Third one is compound microscope. A simple microscope has a limited maximum magnification less than 9 for realistic focal lengths. For much larger magnifications, one uses two lenses, one compounding the effect of the other. This is known as a compound microscope, as you can see in this diagram. A systematic diagram of a compound microscope is shown in figure. The lens nearest the object, called the objective, forms a real inverted magnified image of the object. This serves as the object for the second lens, the eyepiece, which functions essentially like a simple microscope or magnifier, produces the final image, which is enlarged and virtual, as you can see in this diagram. The first inverted image is thus near, at, or within the focal plane of the eyepiece, at a distance appropriate for final image formation at infinite, or a little closer for image formation at the near point. Clearly, the final image is inverted with respect to the original object. The linear magnification due to objective, namely h dash upon h, is equals to m naught is equals to h dash upon h is equals to L upon f naught. This one is equation number first. M naught is equals to h dash upon h, or m naught is equals to L upon f naught. This one is equation number first, where we have used the result tan beta is equals to h upon f naught, or tan beta is equals to h dash upon capital L, as you can see in this diagram. Here h dash is the size of the first image, the object size being h, and f naught being the focal length of the objective. The first image is formed near the focal point of the eyepiece. The distance capital L, that is the distance between the second focal point of the objective and the first focal point of the eyepiece. Focal length Fe is called the tube length of the compound microscope. As the first inverted image is near the focal point of the eyepiece, then magnification ME is equals to 1 plus capital D upon Fe. This one is equation number 2. When the final image is formed at infinity, the angular magnification due to the eyepiece is ME is equals to D upon Fe. This one is denoted by equation number 3. Thus, the total magnification when the image is formed at infinity is M is equals to M naught into ME is equals to capital L upon F naught into capital D upon Fe. This one is denoted by equation number 4. Clearly, to achieve a large magnification of a small object, the objective and eyepiece should have small focal lengths.